Good morning, ladies and gentlemen. Let's start with our joint ERCI and STARS webinar on testing the track with modern means. And at first, please let me describe the background of this webinar, say something, some words about ERCI and the STARS project. Yeah. ERCI is existing for more than 10 years. It's the European Railway Clusters Initiative, which has been founded in 2010. And nowadays, a legal entity based in Brussels has been created, and it is in operation since a few weeks. 15 railway clusters are supporting the European Railway Clusters Initiative, and they are covering over 2,000 companies and institutions in 16 European countries. Most of the institutions and companies are small and medium-sized enterprises, and for sure it's not only the industry, but also the entities from research and development. Yeah, our support is mainly addressed to small and medium-sized enterprises. It's a contribution in research and development, in entering new markets inside Europe, but also outside Europe. To improve the visibility on European level, that is one of our major topics. To give small and medium-sized enterprises in the railway sector a face on European level. And for sure, we try to matchmake our small, medium-sized enterprises together, and also with other industries, scientific institutions, due to several matchmaking possibilities, and we give them support to enter research and development projects on European level. I have to mention that we are concentrate in our work on future topics, and not only topics which are coming directly from the railway sector, but also topics which have a major influence on the railway sector, like cybersecurity, multimodal logistics, green and sustainable mobility, norming and standardization, and human factors. That are the topics of our ERCI task forces, and therefore we try to bring major actors of these topics on European level together, resulting, for instance, in development of new RTD projects, and also for market opportunities. Then we want to introduce the community on the results, on the innovative results of especially small and medium-sized enterprise. And one thing is the ERCI webinar series, which you are taking part today. Our annual highlight in ERCI is the ERCI Innovation Awards. We have them, the awarding ceremony in September 2022 at the InnoTrans in Berlin, and for sure we will have one further competition in the next year. We are present in the internet and at different social media, and you can here see our webpage and some QR codes which lead to Twitter and LinkedIn. Yes, some words about the EU project STARS. It's on strategic alliances boosting railway SMEs, and 10 of the 15 ERCI clusters are taking part in this project, plus 5 technology centers, plus 1 digital innovation hub, and plus 1 blockchain provider. And the major goal of this project is to support the European small and medium-sized enterprises in successfully adopting advanced technologies to boost products, services, manufacturing processes, and organization. And the first step is to clarify how digital mature European SMEs are in order to apply advanced technologies in their processes. And there is a survey online where European small, medium-sized enterprises in the railway and mobility sector have the chance to contribute. And if you are such a small, medium-sized enterprise and have not been contributed to the survey, kindly ask you to do so, because this is the first step in order to give some more support, to get some more support due to the STARS project. The idea is to tackle these 8 mentioned innovation trends which are driving the development of products and services in the rail sector until 2030 with advanced technologies. And some examples of such advanced technologies are in this cloud to be seen. And I think it's no surprise that there are some keywords standing here. And our webinar especially is dealing today with the topics of augmented reality and artificial intelligence, and let's see what our 2 presentations can contribute to these topics. Yeah, the services can be provided by the STARS project are for the first business support and technological support. Business support in order, if you have a use case which you plan to update with advanced technologies. There might be some funding opportunities in your region or on European level, and we try to matchmake you with tech-savvy small, medium-sized enterprises which have much experience in advanced technologies, maybe lower experience in the railway sector, and you have the possibility to discuss your use case with tech-savvy SMEs, with technology centers which are present in the project, and also with the cluster management organizations which are partner of this project. Business support is the one point of supporting your enterprise. The second one is technical assistance, especially by the technology centers. And the third level is the so-called hack and match events. These are events which can bring you together with solution providers due to your certain challenge. If you take part in the survey, you have the chance to be a part of one of the 15 strategic alliances, international strategic alliances, consisting of a minimum 10 small, medium-sized enterprises from minimum 3 European countries to discuss your challenges and your use cases. Yeah, you find some more information on these hackathon opportunities at the STARS Europe B2Match webpage, where you will have the chance to register with a small profile and to introduce your demands you have in adopting advanced technologies for your use cases. The STARS Hack and Match events, the first one is still running, but there will be 4 another Hack and Match events, and everyone could participate, tradition-oriented SMEs as well as tech-savvy SMEs, startups, academia, research centers, technology centers, and so on, also large industries and stakeholders of the railway and multimodality sector. The topics and the challenges which will be further elaborated by the Hague and Match events are coming from the discussion of the strategic alliances of the STARS project. And I repeat, if you want to be a part of this, please enter our survey, and then you will be matched into one of the 15 strategic alliances. Yeah, what will be your benefit from STARS? You could publish and showcase your products, projects, services, or business leads to the event participants. You can initiate and arrange pre-scheduled one-to-one B2B meetings. You could generate fresh leads and meet new contacts, and you could be one step ahead of your competitors by being seen and visibility present at the event. Yeah, and the top 5 objective to make your participation a success is to meet partners and customers, to discover new products and services, to prepare purchases and projects, to meet new suppliers and get information about latest trends. So now we are in the beginning of having the first presentation, and as Professor Hoyer is a member of Rail.S, I first hand over to my colleague Christine from Rail.S, who has the task to introduce Professor Hoyer a bit, and then let him start with his presentation.
Okay, then thank you very much, Lutz, and good morning, everybody. My name is Christine Lawrence. I'm manager at the railway industry cluster Rail.S, and I'm responsible for the strategy as well the PR. And I'm very happy to present you one of our 100 or more than 100 members from industry and research. And I'm very happy to introduce you today to the Fraunhofer Institute for Ceramic Technologies and Systems. And Fraunhofer IKTS, it's not just a member, it's also an awarded member, because the Fraunhofer IKTS got in 2021 one of our innovation awards for the SONIQ Rail Explorer. And this is technology what you see here on the picture. It's a mobile track inspection system, but I don't want to tell too much, and that's why I want to hand over to Professor Dr. Hoyer. But before I forget it, just one organizational hint. Please, if you have any questions concerning to the presentation and to Professor Hoyer, then please put your questions in the chat, because we will come back to your questions after the presentation. And now I hand over to Professor Dr. Hoyer from Fraunhofer IKTS.
Yeah, thank you very much for this nice introduction. Hello and good morning, everybody. I will share my screen.
Perfect. We can see your screen.
Okay. Then I will start my presentation. Yeah.
Perfect.
So I come from the Fraunhofer IKTS, from the Department for Testing Systems, and I will give a presentation about 2 new developments. One for the wiring and repair parts inspection of the catenary wire, and then I will come to augmented reality for track inspection. First, very brief introduction to Fraunhofer. So Fraunhofer is one of the largest research organizations in Europe for applied research. So we are not focused to fundamental research, so we are applied research. So we are transferring technology from universities to industry and doing the prototype phase and so on. We have close to 75 institutes in Germany, and every institute is dedicated to a very specific topic. And our topic from our institute is ceramic technologies and systems. So it's a material research institute. And inside this research institute, we have a department where I'm responsible for. It's a department for material diagnostics. And inside this department, we have 150 scientists and engineers dealing with any kind of non-destructive testing. Ultrasound, eddy current, X-ray, and everything what you know. The today talk is about ultrasound. So I will focus to ultrasound. In the field of ultrasound, our institute has everything in our own hand to make ultrasonic inspection systems. So it starts with the preparation of very specific piezoelectrical elements. So we are a ceramic institute, so we have a powder department and we can make our own piezoelectric elements. Sometimes it makes sense to adjust the piezoelectric parameters exactly to the requirements of the application. Yeah? So from the piezoactive materials, we have a group which can produce ultrasonic probes, so with the damping unit, with cabling, wiring, matching, and so on. We have a group, a department for electronics, so we have our own ultrasonic electronic platform. For sure, we are not producing this, but we are the developers, the designers, and we are responsible for every design step. The simulation and software department, a robot department, so they can construct manipulators and we can build these manipulators. And last but not least, there's a certification lab, to give a stamp to this technology, to apply this in safety relevant applications. Some examples, robots become more and more important in NDT, especially for aerospace application, so parts of turbine engines or fuselage components, but also in automotive industry. What you can see here, it's a single arm robot. It's an eddy current probe scanner to measure the fiber orientation in carbon fiber structures. So it's a high frequency eddy current for carbon fibers. What you can see here, it's a dual arm robot with squirter technology for turbine engine fan blades. At fan blades, you do not have parallel structures. Everything is curved. So the key innovation here is a so-called beam tracer algorithm. So the sending element is always perpendicular to the surface. This is standard, but the receiving element is the position of the receiving element is calculated by the expected sound outcome from the blade. And we can do this on the fly. So during the scanning process, the receiver is always looking for the maximum of energy comes out of the blade. So it's a beam tracer dual beam robot based on squirter. And what you can see here, it's a robot system for human interaction. So you do not need a security fence. So the worker can stand directly beside the robot. So the robot is doing the ultrasonic NDT on the large areas, and the person is doing the ultrasonic NDT on the very critical geometry parts. Yeah, so to increase reliability and safety and speed. But we're also developing scientific instruments, for example, ultrasonic goniometer for scientific research with ultrasound on materials or ultrasonic microscopes. And in the railway sector, we are very active, for example, for the hollow shaft inspection. You can see here an inspection system for ultrasonic inspection of German ICE shafts from the ICE train. Currently, we have over 200 of these inspection systems in the market. Today, we are not directly going to the market, so we have a collaboration with companies who are bringing the inspection system to the market, but you will find our Fraunhofer core components in every of this inspection system. And also the solid shaft inspection for the heavy weight carriers. For example, here, this is an inspection tool together with Axis Tolina. It's a Berlin company. It's a solid shaft with a wheel and the brackets. And the solution here is a phased array-based solution where you have 4 manipulators. Every manipulator is handling a phased array probe. And you can do, with beam steering, the full inspection of the solid shaft. And inside these systems, we have our Fraunhofer own ultrasonic electronics, the Picos, for example, is a 128 native channel system, so you do not need multiplexing. You can use it for beam steering or for parallel operation of probes. Or the modular software suite with all the interfaces for automatization. It's not directly related to ultrasound, but to acoustic techniques, especially for big cities. For example, in China or in Asia, they developed a new generation of public transportation cars. And they use lightweight structures because if you have to accelerate and decelerate a car very often, then weight matters. With the ECE high-speed train, weight is not the critical issue if it's on steady, constant speed. But if you have to accelerate and decelerate very often, the weight matters. For example, there's a possibility to reduce the weight from the car itself by using carbon fiber structures, but also the bogie, the Drehgestell, bogie, can be made from carbon fibers nowadays. And you know, this is a very critical part. So security NDT inspection has to be done on this part. And this is not so easy if you have a very complex shaped carbon fiber structure. And we developed a solution based on acoustic sound emission. So we have a bogie and we put our high frequency microphones on the bogie, and then there's a mechanical load system, so we can bend the structure. And during the bending of the structure, the carbon fiber structure will emit sound. This is not destructive, it's non-destructive. So if the load is below the critical value, then you can listen to the sound during the movement of the structure without destroying the structure. But with the microphones, you can detect and you can do a localization of the sound source. And then you get images like this. So we have, for example, here some red points and here some red points. And by changing the mechanical load, you can look on which part the structure is emitting sound. Yeah? And if you have some experience and some a priori knowledge, you can decide, okay, this bogie is valid and can be used in the train, or this bogie has a problem and has to be repaired or scratched. Yeah? So this is sound emission. You also can integrate sound emission and accelerator probes into the hollow shaft for high-speed trains. And the task then is that you can combine a monitoring of the wheel set during operation, and in parallel, you can acquire some information about the track itself. Okay, now I will come to the topic of catenary wire inspection. Catenary wire, so if you have electrified tracks, you have the contact wire where the pantograph is contacting on, and you have the messenger wire where the power and the mechanical stability is supported. And yeah, during the years, sometimes you have to repair these wires. And typically, these repairs are done with these sleeves. Typically, a repair has to be done outside during stormy weather. Yeah, so the staff has to handle hydraulic presses, yeah, over the head in stormy weather, and sometimes it can happen that they have a misalignment and of the tool, or maybe there's dirt on this part, and they found out that over the years this sleeve can fail. So there is, for example, during this production, an initial crack or a scratch on the surface, and the scratch can grow over the years during summer and winter time and during the mechanical load. Yeah? And they found out that many of these repair parts have critical cracks inside. Yeah? And it takes some years. Here you can see a fully cracked area, and here the crack maybe covers 1/3 of this area. And it's just a question of some month or a year, then this sleeve will fail and the wire comes down. Yeah? And typically the wire comes down not in the nice summer weather, the wire comes down during winter, during stormy weather, and so on. So when you don't want to have repair stuff outside of the track. That's why, together with our customers, we developed an ultrasonic tool. Can be applied overhead on this wire. We have, for example, with this kind of repair parts, 6 probes. So here are 6 ultrasonic probes inside with an integrated multiplexing unit with some wedges, and the acoustic process is that we couple in the ultrasound, and then we have an internal reflection from one probe to another probe. And if this path is interrupted, then we know that somewhere are cracks going from inside to outside or from outside to inside. Yeah, this system is now available, and it's at the ÖBB Austrian railway sector in the test phase. Yeah, here you can see a video. During the measurement, water comes out. This is the first prototype, and we found out very, very fast that the water dropping down is not a good solution because the water goes into the clothes of the engineer. So the current situation is without this water is with the gel coupling. So, but it works well. So this is an example how Fraunhofer is doing development of new approaches for NDT. If this development is successful and accepted, then we will give a license to a company who is producing this and who's bringing this to the market. Okay, now I will come to the SONIQ Rail inspection, especially with the approach of augmented reality to support this track inspection. As you have seen in the entrance slide, so together with this German company Vossloh, we developed a new generation of ultrasonic track inspection. So this is a manual system. So if the inspection train, for example, has a indication, a defect indication, then typically the testing staff is asked to go out to the track and do a precise measurement to decide do we need to repair the track, or do we have to cut, or it's an acceptable defect. So it's a high precision ultrasonic inspection system to make a precise measurement of the track orientation and so on. Here we have some advancements. So typically track inspection is done by gliding probes. So the probes gliding over the surface. This probe gliding has advantage and disadvantage. One of the big disadvantages is you need much water for coupling, and the probes they have a limited lifetime. Yeah, so this problem can be solved by a ultrasonic inspection wheel. So we have the ultrasonic probes inside the wheel. We have a coupling liquid inside and a rubber wheel, and the wheel is moving, but the probes have a fixed position without gliding contact to the track. The second innovation is that we have an optical camera system. So we have an optical video, and we can combine the position of the video with the measured defects. Then the system is very light because it's a manual system. So you have to carry this from the car to the track. So the overall weight has to be less than 20 kilograms due to the European safety work regulations. Yeah, and you can fold this handle so that you can put this device into a standard car. So far, this is more or less standard ultrasound, but a new interpretation. The technical innovation is the combination of this system with augmented reality. Yeah, so the concept is that you are doing this 3D ultrasonic inspection of the track, and the data are directly live transferred to, for example, this HoloLens, and then the operator can have a view over the HoloLens to the track, and he can see the ultrasonic data overlaid with the reality. Just a small video how this company is telling this story to the customers. Yeah, so some parameters. Yeah, so you can see it's a water supply, but a very small amount of water you need for coupling. The rotating ultrasonic wheel. These red wheels are used for backwards and forward steering. The ultrasonic delivers a resolution in the range of millimeter, and the camera. Overall, there are 9 probes with different angles, so 30, 45, and 90 in forwards and backwards direction. The traditional view to the A and B and C scan, together with the video stream. Yeah, and now you can see the vision with augmented reality. So put on the glasses and have a direct view to the track. Yeah? So the green one, this is the artist impression of the ultrasonic data. And green are from the geometry of the track, and the red are the indication of anomalies. So in the moment, we are using the HoloLens from Microsoft. From our point of view, it's the most advanced holographic augmented reality system. And with every generation, these lenses become more and more robust for industrial applications. Yeah? They started with some glasses which are maybe used for scientists and in the home consumer application, but this technology becomes more and more usable for industrial applications too. And here you can see the view through the glasses to a track, for example. So this is augmented reality, means you can see the reality overlaid with digital data. And the green indications are indications from the geometry. It's not a defect. These are indications from the geometry. And the red points, these are defects inside the track. And in the moment, our software is able to stream this directly live after some seconds from the inspection system to the glasses. So you can have a more or less instant view to the data. And if you are able to visit my institute in Dresden, I can give you one of these glasses. It's impressive because if you go closer to the part, you have enlargement. You can see very precise details. And if you go far away from this, you have a large overview about the general situation. So it's very easy to understand where the defects are located and how the situation is. This is the live stream in the laboratory. Yeah. Also, maybe if you don't want to use it in the field, you can use it for doing the parametrization in the laboratory or in the job shop. So it's very impressive how the system works in the moment. The most important point is that the probes in the glasses have to identify the track, or they have to identify the object, and then we have to adjust the coordinate systems from the ultrasonic data and from the reality to have a precise overlay. So there the most part of the software development goes in. In laboratory environment, it's more or less easy to fix the coordinate systems without marks. So you have to use the natural points. But if we go outside to the field, then we have a very small amount of points where we can fix the coordinate system. Maybe a tree, maybe a stone. But in the moment, yeah, the research works is going to make this very robust working for industrial applications. So the overlay of data in the field outside. Okay, what is the motivation behind? The main motivation is with augmented reality, you can have a fast access to complex and difficult interpretable industrial data. Yeah? Typically, you need well-trained staff with many years of experience, to make an interpretation of a complex ultrasonic result, and to make a decision. With this HoloLens approach, the decision-making process is supported and the understanding is much better. So bringing new stuff to fast operation is one idea. And the second point, is, for example, railway industry is a very old-fashioned conservative industry. And with this augmented reality and the digital approaches, this industry can be more attractive to young engineers from the universities. Yeah, so to keep this old-fashioned industry more modern. Yeah. Okay, the data interpretation in the field is only one application for augmented reality. Yeah, but there are many other possibilities. For example, for teaching. So if you have to teach the testing stuff, yeah, then you can use also this augmented reality approach to help them to understand and to learn how to operate the system. And also in the case of repair or maintenance, if you have outside, far away from your job shop a problem, you can help fixing these problems by this augmented reality approach. So to use this augmented reality, for example, for fixing problems, it is necessary that at least two persons can dial in, can come virtual together. One person has the virtual environment, so virtual augmented reality. The other person has virtual reality. So he sees what the other worker sees, and they can both work together in this 3D environment to fix problems, for example. Here you can see the dual user approach. Yeah. So one user, for example, is outside in the field. He has a problem and he is pointing to the problem. And the other engineer is in the office and he sees what he tries to tell him. And then they can use the sound to talk or mobile phone. And they can use this 3D visualization to help and to fix. For teaching purpose, yeah, we have the possibility to have this teaching, schooling approach. So you have some buttons, you can press on the button and you get explanations, informations, how to operate, how to make maintenance, how to fill the coupling water in, and so on. So it's like a user manual, but in 3D, so that the teaching effect is much faster and more efficient. And also, if you want to make a decision together, if you have to interpret data, then it's necessary to make some marks. Yeah? For example, with the finger, you can circle in a defect and you can type some protocol information. And yeah, step by step, this software becomes full functional, to have all these possibilities. So the engineer outside in the field, he can mark in this 3D image a region of interest where you have maybe a question, and the same indication can be seen by an engineer with his glasses inside the office or on the other continent, and then they can discuss and write a protocol together. So what I've shown to you is advanced augmented reality. So there are many institutes and companies on the way to do this, but at the final end, this is the first step to the industrial metaverse. I think you have heard about this word metaverse, yeah? So that you have a virtual reality where you can deal with other persons, where you can make some digital business. And industrial metaverse is the industrial part of this metaverse. For example, where you have a company in the digital environment and staff members can come together on this machine, they can discuss, they can make recipes and programs. And this is the final end, that we have the tracks, the inspection, and all the data in the virtual environment. Then the ultrasonic data comes through this metaverse for decision making and to look how the data are changed over the years, for example. So far, I provided you many information about our visions, and I'm happy to show you these approaches here in Dresden. So if you are able to visit the Institute in Dresden, you are always welcome. And yeah, if you have questions, please come up with questions, and I'm happy to answer these questions.
Okay, then thank you very much, Professor Heuer, sorry. And yeah, there was a lot of information, a lot of solutions, and I can tell you we have also a lot of questions for you.
Okay.
I would say we start with the last solution, the mobile track inspection device. The question is, for example, which is the track length that can be inspected during 8 hours?
Okay, so the system is not designed to make it 1 hour inspection in one shot. You can do this. So 4 kilometers as in one data set is not problem. So the software can handle this amount of data and the video stream too. So there are no limitations in the software, and the amount of water you have maybe takes 3 to 4 hours. So maybe you have to refill the water once per 8-hour shift. And with the battery, so there's a changeable battery, yeah, accu pack. I think one battery pack covers 6 hours. So typically you are not doing inspection for 8 hours in one stop, but doing inspection, make a protocol and so on, and then one battery charge can cover a 8-hour shift.
And how fast is the mobile device?
It's a typically speed a human being is running. I don't know the kilometer per hour, 4 or 8. So I think we have tested this until 8 kilometers an hour. So it's a fast running. Yeah. Yeah.
Okay,
So
perfect.
this is it's a manual system to be moved manually over the track.
Then I think the next question was also related to the inspection device. Which are the main defects that can be detected?
Oh, therefore, I want to connect you with this company Vossloh. Yeah, so we have a catalog of defects, for example, cracks or head sheds on some. Yeah, so the typical defects you have in tracks. Yeah, I will connect you with this company, or if you write me an email, I can give you a publication about this where all the typical defects are listed in and the resolution we can acquire.
Okay. Then the next question was concerning the track inspection device. To put augmented reality information over real objects, you need an exact coordinate system. How do you solve this?
I try to explain this. In the laboratory environment or inside a room, if you look, yeah, you have points, the wall, the window, the cupboard, and so on. And this helps you to fix the coordinating system. So inside rooms works very well. But if you go to the field outside, maybe if you have just a field with grass on it, then you have a very small amount of points where you can do the referencing to. In the moment, it seems that small points in the track, for example, the stones or so, are enough to fix the coordinate systems. Yeah? In the worst case, maybe you need Kreide or a mark with a white spray or something like this. Yeah? But in the moment, we are looking forward to solve this issue without artificial marks, just with the points the reality gives us.
Okay, thank you. If the question is not fully answered, please, you can also talk to us. Yeah, you don't need to take your questions in the chat now. So the next question was, I'm not sure, is it really related to the track inspection device? Is the detection device for tracks problems is permanently installed on board trains? That's the one,
Okay,
the first
this
one.
was this one example. It is a possibility. So there was a project together with Siemens, I guess, the instrumentation of the existing wheel to make wheel monitoring and also track monitoring. And from my point, it is not end up in a used product. It's just a prototype. We have shown what we can do, but it's up to the company to make a business case on it and to decide to spend the money or not. Yeah. But in this case, it has to be installed in the track, in the hollow shaft. Yeah.
Yeah, and does it use ultrasound measurements?
So I will.
Was the next question.
So you mean this? So this is a system for permanent installation in the hollow shaft. Yeah.
Okay, and the last one was how to detect problems in a railway noisy environment.
Yeah, this is done in the frequency range. So we are acquiring data in the very broad frequency range. So with very broadband microphones, and the lucky thing is that you can distinguish between the noise from the structure and the noise from the environment by looking to the frequencies and to apply some algorithms to the frequency depending noise exposure. Yeah.
Here's the next question. And with the picture in the chat, okay, it's interesting that it works. Do you have double-sided measuring systems, which is driven by a truck on railways?
A double side, you mean?
There's also the picture in the chat.
So what you can do is you can combine two of those mobile systems with a bar, and then you can move on the left and on the right side two systems as one operator with one screen. This can be done. Yeah.
Perfect.
And to bring this, with a motor to a self-propelled system is just engineering, let's say. Yeah.
Here's also is it a new one? But let's do we have the time for more questions? That's the question.
Yeah, I think we could answer one more question.
Okay, I'm not sure. Is it a question? NGRT can give exact monitoring of the infrastructure with analysis of ultrasonic vibrations without using any manual operated solutions. But it's more who is using it. I think it's more a statement. I would say. What is NGRT? I'm not. NGRT is the okay.
It's a company, yeah.
Okay.
Yeah, from Spain.
Okay.
Yeah,
So
but I have one additional question from James, who is using. Oh, I cannot read it, but I will put it into the slide very quickly. Just a minute. I'm not as quick as requested. Who is using it in China? Are there any application case already in China, or?
So this hollow shaft inspection system, most of our systems are operated in China, not exactly by CRFP, but by operator of the trains. Yeah, I can connect you with this company Access. You have to connect Access, or you please go to the internet page of Access, and I think you will see the distributors and the users in China. Otherwise, write me an email and I can connect you to this company Access, and they will give you the reference list. Yeah.
Yeah. For the moment, Access is not longer a Berlin-based company, but a Brandenburg-based company. And we have the contact data as well as you will have the contact data of Access. And I think if you, James, write a direct email to Mr. Hoyer, you will be provided by the contact data. And at the end of each presentation, you will find for sure the contact data of the presenters. So it is an easy exercise to get in contact with them.
But China is the largest single customer for the country.
Yeah. All right. I think we should proceed with the next presentation. Professor Hoyer, thank you very much for this interesting insight into using augmented reality for testing the track. And the videos were very impressive also to me. and the presentation is quite big for sure for the participants. You will have a simplified short presentation then. The second presenter is Dr. Daniel Kanzler from the company Applied Validation of NDT. And the topic is reliability of non-destroyable technologies in railways, how to optimize the available testing techniques. And as I see for the picture, that's a project funded by NFund. That is a funding instrument from the German government, from the Federal Ministry of Digitalization and Transport. Daniel, the floor is yours.
I still need some rights. If you can give me to that, then I will start with my presentation.
Yeah.
But until then, thank you very much to have the opportunity to talk about this project.
You have the right. You can simply share your screen.
Oh, perfect.
And then my sharing will be destroyed.
Okay, perfect.
Also only switch to the presentation mode, and the presentation could be started right now.
Okay, should be like this, hopefully.
Yep.
Perfect. Thank you. For me, it's quite interesting because you are seeing right now two presentations, and two are about railway and two are for some specific part of it. However, I want to not dive directly into like non-destructive testing and the testing techniques and railway. However, I want to start with the idea, why are we doing that? And just last week or the week before, there was like a court sentence of one European railway company because of some failing rails. And the reason for that was a technical issue. And especially from the German point of view, this was quite, well, familiar for us, because we had in the middle of this year, we had also some issue with the railway. And it was also because of a technical defect. So even when we are thinking of our high sophisticated technical environment, failings are happening. And this brings us to some specific situation, especially in railway. This is that in the middle of the company, there is someone who gets a lot of pressure. He gets the pressure from the company. He gets the pressure from, let's call them direct stakeholders. And they got the pressure from the society. And when I just think in this point of view about the railway, and you see, I open really up the field right now. In Germany, it's quite interesting. We started with a €9 ticket. The later, or which will come maybe this year, maybe beginning of the next year, the €49 ticket. So these simply like ideas, which are quite important, they have a lot of influence, because more assets are necessary, more personnel are necessary. The maintenance intervals should be longer. The quality insurance costs, so a lot of about the costs need to be lower. At the same time, we are in the middle of this, let's call it old critical infrastructure. You have heard, well, railway is not a topic of a few decades, but almost a century. We have old bridges, for example. At least in Germany, we have 4,000 bridges which should be like renewed in a way. Not all of them are railway bridges. However, the infrastructure is kind of well, old, and to handle that in a way that we don't end with a failure, we need to do a risk class assessment, which is working. Of course, we need more personnel. So of course, the costs are rising again, but it is impossible to just renew all of the bridges directly. And about the bridges, well, also there we had some issues in the last weeks and years. And then we should keep in mind that we are in a situation which is very critical for like the surviving of the Earth. We are talking about like sustainability, and a lot of opinions, especially in society, is that the train is in a lot of cases, it is the solution for example, transporting the people from one part to another, or also the goods. So the competition to the car, the competition to the airplane. And when we are talking about competition, then we are talking about costs, but at the same time, about the higher service quality. So you see, whatever I put in at a question mark in the middle of the, let's say, railway company, there's a lot of pressure. And I think this is not only one person, this is a group of people, but one of the key people there is the engineer. The engineer, for example, for quality, the engineer of testing, but also the engineer for designing, etc. Because only they have the solution to solve these problems. But at the same time, when something like the two pictures I showed you before is happening, then questions are rising. Why didn't anybody do anything about it? Why wasn't it detected before? Was it maybe like in a criminal purpose that he did not connect it like this? You might smiling about this criminal one, but just think back like 1 year ago about the automotive situation where they did some kind of mistesting of motors, etc. At the same time, the technical failure will be evaluated through, for example, modern technology in a much better way. We know much more about it. I don't need to start that everybody is running around with a mobile phone, but there is a large potential of improvement. So there is potential that we can handle that. At the same time, we have large discussion, for example, in network. We saw, for example, at the very first beginning, yeah, we are at Instagram, we are at, of course, everything is connected, which helps to understand, which helps to learn, which helps to really solve these problems. On the other hand, we have a lot of, like, let's call it opinion. And I don't need to say, for example, the COVID the pandemic, the opinions of known people in the field, experts, are sometimes not so easy to, bring it on the right track. But exactly here we need to start, because they are the people in our situation who can solve the problems. And as soon something like this is happening, the spotlight, like the time where the pressure is, for example, on the engineers, are huge. It is short. This is also interesting. It's short, but it is massive. So how can we help them? Well, in my opinion, we need to give them the opportunity to solve the problems, and one of them are standards. And this is why I want to talk a little bit about the standards, because in my opinion, this is the only way that we can go into the future. We can keep, for example, railways going. We can improve the situation even more, and we can make it in an objective way. And even if we have like this, okay, it's slowing down developments. Well, I'm not quite sure about this, but it is pretty clear then when we are talking about standards, then it's a quintessence of experts. So this a little bit about the standards, why I was doing that, I will show you soon. But first, let's talk about reliability of testing. So you have heard already about a lot in the first presentation about non-destructive testing. So the testing is an essential part. The question, however, is when we are talking about testing, what do we want to find? Is it the smallest defect we can detect? Is it the smallest defect we can detect reliable? Or is it the largest defect we might miss? Even in this quite simple question, when we are really talking about why are we doing this, we see that all of these three questions will give a slightly different answer. And with two, I'm okay, and with one, I'm not. The very first one, that is, let's say, equipment-driven, or maybe even like research-driven. We found some, for example, a pore in some component, or for example, the smallest crack we ever found in rail. The large one, that is what the first two slides was about. So that makes pretty clear it is not the first one we want to decide when it's in the field. It is quite important to know it because that gives us an idea, is the system at all useful? But when we are talking, for example, about risk, about failure, then it's the last one. And now I don't want to introduce too much graphs and too much topic into that, but I want to show it because it's a wonderful curve. It's my favorite curve. It's a probability of detection curve. So the probability that you can find a defect. And you have the defect sizes. And you have here the largest missed defect. And you have here the smallest defect to detect. And you can see they are not really the same one. This one is larger. And this we should keep in mind when we are talking about risk. And below this, it's called A-9095. It's from aerospace. This is what we are calling the smallest reliable detected defect. And this is what we can use, for example, in calculation of structural integrities, etc. I will show you this curve in a slightly different way, but you need to believe me at that stage because I don't want to make a deep dive into POD. The POD is also like here. So this one is a cumulative one, and this is the not cumulative one. The interesting part, and right now I think I can just close it a little bit back to what we are talking about, for example, about rails. You see the blue curve, and this is, for example, a crack. And the crack is getting larger over time. And at the very first beginning, we can't detect it even. It is so small, we can't detect it. But after a while, it's getting bigger and bigger. And at the end, it is so large that it is a critical crack. A critical crack means at that point, we should detect it. However, and right now it gets a little bit more complicated, we are talking about probabilistic situations. So we can't say it's exactly this curve, but it's a band of curves. So it might be here already critical, or it might be here already critical. And when you have that in mind, and this is just a statement, this is not a theory, then you need also to have the idea that your testing system is not finding 100%. I showed you that in a kind of here in this curve, but it has a probability of detection. And then I want to ask you right now the question, what is about predictive testing intervals? Without both information, it is absolutely impossible to get like predictive testing intervals, which are not at the same time, etc., etc. So all the testing intervals we are talking about the rails, but we also talk about wheel sets. We are talking about everything which is critical. We have to have the idea of both information that we can talking about testing intervals. And this is a little bit why the whole reliability is about. So I told you about standards. This might be quite new for a few people which are in the field. In September 2022, the German Standardization Committee reactivated one group It is called NA620828. And this is about qualification of non-destructive testing methods. So exactly what I showed you before will right now end in a German standard. Not only the curve, but how to calculate it, what to do, the design of experiments, etc., etc. However, there will be a standard for this. And in this standard, of course, railway people will sit inside. And of course, when we are talking about DIN standards, well, then the next step might be a sense standard, and then all of us might have some, connection point with that. And the curve I showed you before, I already gave you the US standard for a similar thing. So the standard's popping up right now, and the question is, when do I need to handle that? I showed you also that even when the topics I told you are pretty well connected, the mathematics are a little bit more complicated. Therefore, we have an international group. It is the AV-NDT, so the International Society for Non-Destructive Testing, which are handling this reliability group. And in Long Beach, in the wonderful city of Long Beach, we will have the 8th International Workshop on Reliability, where we exactly discuss these connections, etc. So for you right now to know, there will be standards. There is a huge discussion of experts behind it to make it correctly, etc. And if you are interested, there are platforms that you can get the knowledge. One part of it is when we are talking about a testing system itself is not just in the environment, but it is influenced by different things. It is influenced by the physics. We have heard, for example, about the ultrasonics right now. We have the application factors, difference, for example, between laboratory and outside of the field, especially for like rails. We have the human factors. So what is the human doing? And the organizational factor. So how is the company reacting? And the newest of that, and this is where I want to go a little bit more deeper, is the algorithm part. So right now, a lot about this is about algorithms. So for example, the artificial intelligence. And for that, I found some, let's say, article from my former boss, and it was from 2002. I need to say 2002, I didn't even think about things like neural networks and AI, which are right now like in everybody's mouth. However, at that time, it was pretty clear the process itself, okay, here it's radiographic, but it doesn't matter. At one point, there has to be an inspector or I would say right now, and a neural network to get something about the inspection. At the same time, right now, when we are saying, okay, AI is the solution for everything, we also realized that AI is failing. And I found here an article from Nature. These graphs are not as important. You just need to see that there are the difference between red and green about the graphs. I could also talk almost 20 minutes. However, the interesting part is the AI for radiographic is selecting shortcuts over signals. And the same thing might happen for ultrasonic. So for us, this is a starting point. How can we handle AI and where can we understand in which direction it is going? And very often, maybe you have heard about explainable AI. Yes, this is exactly our direction. And this is where this project is coming to start. In this project, yes, you see the UT equipment here is a little bit larger than in the first presentation. So this is the trains running over the rails to just find exactly the, let's say, critical situation where we need to go directly in person to go there and find it again. So when you just think of the rail net in Germany, I think it was something like 80,000 kilometers, but don't I'm right now not 100% sure, but it is really a lot. So you have a lot of data, and right now you have a human sitting in front of this. So our task is, how can we improve that situation? And this is not only like from one part, but you see there are different players in it. It's a 3-year project. Let's say it started a few months ago. You have DB Netze. Of course, we need to test something. You have BAM doing let's say the testing part with ultrasonic and eddy current. You have the TU Berlin about the AI algorithm, and myself. You can find me at this situation in the Frana GmbH, and we are talking about what is reliable and where do we get like the reliability of the AI system or the testing system itself. And one interesting part is all of them needs to be connected. So the data needs to be connected. And this is one topic we are talking about NDE 4.0. And this is done by CEDAS. And another level, and there you see how important is it like to grab it as a full system. This information has to be, used somewhere. And there we have the Eisenbahnbundesamt, and they are doing, they are interested in the maintenance planning because they need to make sure that then the information we get from here are really working. So what we are doing, I want to give you, because right now we are in the middle of including an AI system, finding the data, producing the data, etc. And from my point of view, the interesting part is, how should we do the evaluation? The evaluation will be on 2 parts. The one part, the AI training, and there you have already seen a similar graph like this in the Nature article, but you see like what is a defect, what is not a defect, what can we find, what don't we find. We put this in an, let's say, IT structure, which is called the model cards. The evaluation will be evaluated by the KPIs, key performance indicators, which are like known in the field. And of course, you need to have there like some data, modeling data. And at the end, we are here again, and we are exactly at the question, the POD, the curve I showed you before about where is my critical defect and not critical defect. And this is exactly the point where everything is connected with the maintenance action planning. So at that point, when we have the idea, these are the informations we get. This is like the capability of the testing system. Then we can, for example, plan. There we can do the risk assessment. There we can like focus, for example, the means in the right direction, or the means on the right track, the means on the right, also for the later for the bridges, etc. However, if any part of this is missing, then we have a problem. So this is right now the direction of it and the aim. If you have their questions, I saw a few of my colleagues are there from the testing side, from the interconnection side. So I'm quite happy to also let them answer the not reliability questions. But I think you see that the interconnection of it is quite important for the future. And I'm really interested if we have the first results of the AI system in a reliable way. If we can compare that with a pure human one, will it be better or not, or what are the differences? So this was my short presentation about reliability, about AI, and as I said at the very first slide as a title. At that moment, we didn't change the testing system. The testing system is still like there. However, the interconnection will be that what will bring us the new value, and which is right now absolutely necessary. So thank you very much. And I'm open for question.
Just thank you very much, dear Daniel. And I have noticed two questions on my next slide, which I will share with you. And the first one is, how much potential do you see in the integration of artificial intelligence?
This is the point of AI is right now, we see it really critical. When I just think of, well, how do we compare it, for example, with a system without AI? Right now, when we are doing PODs for or reliability evaluations with just a human being, we don't have a situation where we compare it. I know from, for example, the human factors evaluations, etc. I see a large problem with humans, for example, sitting 8 hours in front of a computer, because we realize that 7 hours of them, they don't find 50% of the defects. AI doesn't have the problem. So there you see already there is a huge potential. However, AI itself, without any human, is also useless. The potential will lie in the correct integration of AI with a human in a structure where you get an idea what to do. But first you need to understand, where are we right now? And I can tell you right now, we are not as good as we are thinking. So the potential is huge.
Huge potential, and I see that also some colleagues of BAM are inside this webinar, and maybe there are some additions to the answer of Daniel, and if not, I will proceed with the next question, and it is regarding the project you funded project you presented. What is the timeline to bring the results of this project into operation? What do you think about?
I think the timeline was the project was running 3 years. So
is it already finished, or
no? It started last year. So I think December last year. So there are still 2 years to go. And yeah, right now I think the things which are done are quite in the timeline. So I expect like bringing it in operation in 2 years. However, the interesting part will be like the framework itself.
Yeah.
So how to framework it, what is the standards we need to think about, and right now, and AI, of course, you know that by yourself, a lot of things are happening.
Yeah, I'm already typing the next question to the slide, and the question is, how is the TRL of your solution by today? For sure, we are talking about a funded research and development project.
Yes, but of course we are talking about really the interest, the industrial use of it. So of course we are not in 1 till 3. For me, it makes it a little bit difficult to just point down and say, okay, this is a TRL. The testing system itself, it's quite high because it's already used. So I don't need to think there about TRL. The introduction of, for example, reliability concepts, it is maybe somewhere in the middle. So I would say maybe some like 7, 8. However, when it's standardized, of course, it gets 3 steps up. I think there is not a clear solution about it. So if you specify it, which part of it, then it would make it a little bit more easier. Or I need to give it then to the right person.
Yeah. Are there any addition to the answer? That's an additional question which I will not type so quick into the slide now, which could be the use case or to which apply it. Was
The
it?
use case? Well, the use case itself is, I think you're concentrating on the project itself. So the use case will be, of course, the testing trains of rails. So we are testing rails. So this will be the direct use case. When we are talking about where can we use the idea of including AI with testing system, then it can be quite huge. We are talking about the whole reliability from civil engineering, so bridges, buildings, etc., until aerospace, automotive. So there's a huge potential field for the reliability, and the same is true for AI. So for us right now, it's more reading literature out of our field, which is quite interesting, but this is exactly like learn from others. And sometimes when you just think of AI, it makes more sense to learn about AI from companies like Google, Amazon, etc., than for a specific field.
Is this a sufficient answer to you, Guido, or you have another one? Maybe you can open the micro quickly and ask your question directly.
Yes, thank you for your answer up to now. I understand that those questions are sometimes tricky. The idea is just to understand better how to apply it, because you have your funds and your program and project in Germany, but we try also to develop something at European level. Therefore, the next question is just to see if what you are doing, and I imagine it's the answer will be positive, could be extended from track to onboard system, because cracks, let's say track cracks as defect, is something that can happen also on, as we have seen before, on onboard train subsystem. Do you foresee also this in your roadmap in the near future? Thank you.
About the international question, so thank you very much. We also have in our audience some Italian expert in the reliability evaluation, which was or which is focused, for example, on the wheel set. The ideas of the reliability is there, and it's not a question about just German-wide. So this is why I mentioned that we have the international group on reliability, because there we have a lot of experts also from other fields, from the US, because all of them have the same questions. And this is one of the answers. And on the onboard train subsystem, I'm not 100% sure what you mean with that, but I right now think of what parts of the train are critical. And the critical parts is the rail, because when it breaks, we have a problem. It's a wheel, and it's a wheel set. And the whole topic about reliability in trains started with the wheel and the wheel set. Michele, I hope that was correct, because there you might be having a little larger knowledge than I do. But so to answer it, yes, it is. It has also something to do with the train subsystem. However, we are focused on the critical part. But maybe when I just think on the first slides, then maybe right now also I call also the bogie the critical part, but maybe also the whole CFK, the new materials which might crack and which might do critical problems, will have there also has to handle the problem.
Thank you for your answer.
Yeah, total agreement raised by Michele. Is there some other questions? So you have the chance to directly open your micro and raise your question. 1, 2, 3. If it is not the case, I want to drive your attention to our short questionnaire, very short questionnaire to be answered in less than 2 minutes to receive your feedback on the organization and the quality of presentations during our today's webinar. And I put it into the chat, and I also have it here on the slide. And I think there are only 2 or 3 remaining slides. There is one slide which I show every time since the last weeks. It is still a big issue to strengthen the resilience of supply chains, and therefore the Enterprise Europe network, with support from the European Railway Clusters Initiative, installed a supply chain resilience platform based on B2Match. There you can register and inserting a short profile of your company, and also your in the marketplace section you can introduce your products, your services, and ask for certain demand. And then you can get in contact with the other participants. There are not only 57, the slide is quite older. These are over 300 participants for the moment. You can ask them to get directly in contact with them in order to discuss how to stabilize supply chains. Then the next ERCI webinar topics, and I put some on the screen, which are very likely to be part of next ERCI webinars. It is for sure that the next ERCI webinar is in 2 weeks, on the 23rd of November, and we have only to fine-tune some details, and I think I keep you informed by my email, providing you with a recording and with the authorized presentations of these of our 2 presenters by today. Then I will inform you also latest on Monday next week with the topic of the new ERCI webinar on 23rd of November, not only with the topic for sure, also with the registration links. And if you have any idea for further topics, please do not hesitate to use our feedback sheet to raise your topics which are of most interest to you. Yeah, if there are no further questions, I thank you very much, and it is 11:30, and we are punctually like Deutsche Bahn and other train operating companies normally are. Thank you very much for your attendance, and have a nice day and a nice time, and maybe we see back in 2 weeks. Thank you very much.
Thank you very much.
Thanks for the
Bye-bye.
organization and the opportunity to talk. Bye.
Bye.